Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this video I'm going to discuss some more past paper questions of P2 International A-Level Edexcel P2 Pure Mathematics 2. The topic is equation of circle, coordinate geometry, and here we have a past paper question which is June 2022, question number 10. The question says that the circle C has center x, which is 3, 5, and radius is r. The line L has equation y is equals to 2x plus k, where k is a constant. Okay, in part A, we need to show that L and C intersect when 5x square plus 4k minus 26 into x plus k square minus 10k plus 34 minus r square is equal to 0. We need to show this equation over here. So first thing first, we know the point x, which is the center of the circle. So we can find an equation of the circle in a completing square form, or you can say standard form. So x minus 3 whole square plus y minus 5 whole square is equals to r square. Okay, since the equation of the circle has the form x minus a whole square plus y minus b whole square is equals to r square, where a comma b is the center of the circle and the radius is r. This is you have studied in basic concepts. So x minus 3 whole square plus y minus 5 whole square is equals to r square. The radius r is unknown. Okay, so what I'm going to do, I'm going to expand these. So x minus 3 whole square is expanded. So this will give you x square minus 6x plus 9. And when you expand y minus 5 whole square, you get y square minus 10y plus 25. And I have shifted this r square on the left hand side of the equation. So minus r square, and this whole thing is equal to 0. And now I'm going to eliminate the variable y, and for that purpose, in place of y, I'm going to substitute 2x plus k. I'm going to substitute the equation of the line into the equation of the circle so that we are able to produce a quadratic equation in this form. Okay, so x square minus 6x plus 9, and then in place of y, 2x plus k, and here in place of y, 2x plus k, and then we do the complete expansion. This 2x plus k whole square is expanded, so 4x square plus 4kx plus k square. And then what I do is, first I simplify the x square terms, so x square plus 4x square, this will give you 5x square, and then I took x as common, so I took x as common, so multiplied by minus 6 plus 4k minus 20, as we have three terms in x over here. This one, and this one. Okay, so I've taken x as common, multiplied by minus 6 plus 4k minus 20, and then the terms which are independent of x and x square, meaning the constant terms. So all of the constants are over here in the form of k and r, where k and r are unknown right now. Okay, so if you knew the value of k and r, you would be able to evaluate the constant, which is the evaluated value of this complete expression, which is highlighted right now. K square minus 10k plus 34 minus r square. But since we don't know the value of k and r right now, okay, so we need to show the equation in this required form. So therefore I can say that 5x square, and then the coefficient of x is 4k minus 26, okay, and then plus k square minus 10k plus 34 minus r square is equal to 0. In this way we have shown part A. All right, and now in part B it says that given that the line is a tangent to the circle, show that 5r square is equals to k plus p whole square, where p is a constant to be found. So when basically the line is a tangent to the circle, okay, so we have substituted the equation of the line into the equation of the circle so that we are able to produce a quadratic equation in this form, okay, in which the nature of the roots will be real and equal. B square minus 4ac will be equal to 0, okay, because there is only one point where the line and the circle meet, okay. So this is basically the whole idea. The nature of the roots concept which we have studied which you have studied in P1, those concepts are being applied over here. Okay, so line is basically the tangent to the circle. So basically, when you substitute the equation of the line into the equation of the circle, you are able to produce a general form of the quadratic equation in this form, in which the nature of the roots will be real and equal. Okay, so b square minus 4ac will be equal to 0. All right, so if you make a comparison with the form of ax square plus bx plus c is equal to 0, so the coefficient of x square is 5, meaning a is equals to 5. The coefficient of x is 4k minus 26, meaning b is equals to 4k minus 26. And c is basically k square minus 10k plus 34 minus r square. Okay, so b square minus 4ac is equal to 0. So 4k minus 26 whole square minus 4 times 5 times this complete expression, k square minus 10k plus 34 minus r square. All right, so in the very next step, I did the expansion over here. Okay, and I did the expansion over here as well. All right, and then I simplified the terms. So I got this equation over here, that minus 4k square minus 8k minus 4 plus 20r plus 20r square is equal to 0. And then I can say that 20r square is equals to 4k square plus 8k plus 4, meaning 20r square is equals to taking 4 as common, multiply by k square plus 2k plus 1, and this 4 will be gone on the left side. So 20r square divided by 4. This 4 comes over here. Okay, so 20r square over 4 is equals to k plus 1 whole square. We can identify the fact that this k square plus 2k plus 1, k square plus 2k plus 1, when we factorize this, we get k plus 1 whole square. Okay, you can just identify that this is the expansion of a plus b whole square, where a is k and b is equals to 1. So here we have factorized this. So k square plus 2k plus 1 is factorized into the form of k plus 1 whole square. So therefore we can say that 5r square is equals to k plus 1 whole square. So therefore p is equals to 1. It's not compulsory to mention the value of p. You just need to find your answer in this form, meaning in this form, which is 5r square is equals to k plus p whole square. So therefore p is equals to 1. So here your answer is completed. You don't need to, mention the value of p, but anyways, I have mentioned this over here. So this was part A and part B. All right. So now let's move on to part C. Okay. So in part C, we have a sketch over here. Okay. The information so far which we know from the question, and so far what we have obtained, a sketch is based on all of the information. Okay. And then it says that the line L cuts the y-axis at the point A. Okay, and basically the line L will touch the circle C at point B, as you can see over here, as shown in figure 2. Given that the distance between point A and point B is 2r, find the value of k. Find the value of k. This is the requirement of part C. So for that purpose, I brought the sketch over here. Okay. And what we know the fact is that the distance between A and B is 2r. And we also know the fact that B and C, the distance between B and C is r, because r is unknown. R is the radius of the circle. And what we also know the fact that the line L has equation y is equals to 2x plus k, as per the information given to you in the question. So basically point A is the y-intercept of the line L. So here we have the point A when x is 0, so y is k. Point A is basically the y-intercept of the line L. So what you need to understand is that the equation which you have, shown in part B, the equation which you have shown in part B over here, that 5r square is equal to k plus 1 whole square. How have you, obtained this equation? You have obtained this equation by considering the fact that, that line L will basically just touch the circle at point B. Okay, line L is basically a tangent to the circle at point B. This fact is already used now. This fact, this information is already used above in part B. Now you need something else. And for that purpose, they have given to you the distance between A and B, which is 2r. You need to make another equation in terms of r square and k, where r and k would be unknown. Or you can just simply say that in terms of r and k, we need an other equation like this. By considering something else, by considering something else apart from this information that the line L is basically a tangent to the circle at point B. This makes sense to you or not? Okay. So what I can see is that the distance between B and X is R, and the distance between A and B is 2r. And what we know the fact is that the radius is perpendicular to the tangent. Okay, so this tells us that this triangle ABX is basically a right angled triangle. This triangle ABX is basically a right angled triangle in which AX will be the hypotenuse. Okay, so I've done some calculation for finding the expression for the hypotenuse. I can say that AX square is equals to R square plus 2R whole squared. So this leaves us with AX square being equals to 5R square, which means that AX is equals to under root of 5R square, which is basically under root 5 into R. Okay, and now what we can do, we can find an expression for the distance between A and X in terms of K. Make sense to you or not? Because the coordinates of A is that when X is 0, Y is K. Alright. And we can consider the fact that the distance between A and X is under root 5 into R. So we are going to make another equation by considering this information now. So for that purpose, I have found an expression for the distance between point A and point X. Okay, so under root of x2 minus x1 whole square plus y2 minus y1 whole square. Point X is given to you 3 comma 5. So under root of 3 minus 0 whole square plus 5 minus k whole square. All right, and this will be equals to under root 5 into r. So we can just whole square both sides in order to remove the square roots. So I can say that 5r square is equals to this expression. So therefore, I am able to, obtain another equation in terms of r and k. So congratulations, we have found another equation which is connecting k and r, where k and r are unknown right now. The first equation is over here, which we have already established from part B. So, I can say that this 5r square is equals to 5r square. I can equate 5r square with 5r square. So I can just say that, k plus 1 whole square will be equals to 9 plus 5 minus k whole square. Okay. So therefore, I'm going to expand this side and this side. So k square and k square will get eliminated. In terms of k, we will be left with a linear equation only. Okay, so 34 minus 10k will be equals to 2k plus 1, and therefore you arrange the terms, and k is equals to 33 over 12, meaning k is equals to 11 divided by 4. K is equals to 11 over 4 is supposed to be your answer. Okay, so in this way we have attempted this question. This part C was worth 6 marks. So you need to be well versed with all of the basic concepts which you have studied in this chapter, okay, before attempting any past paper questions. And you need to be well aware of the information which you have already used and the information which is left to be used. Okay, and you need to just think about it, how to make another equation in terms of R and K. Okay, and which I have already explained this in detail over here. So this was basically the question which we solved over here, which is June 2022, question number 10. So now let's move on to the next question. After this, we have another question which is June 2024, sorry, October 2024, October 2024, question number 10. So the question says that the circle C has equation x square plus y square plus 4x minus 30y plus 209 is equal to 0. The requirement of part A is to find the coordinates of the center of the circle and then find the exact value of the radius of the circle. So expanded form is given to us. So we are going to convert this into a completing square form. So for that purpose, first I have rearranged the equation. So x square plus 4x plus y square minus 30y. Okay, and the constant term is sent on the other side of the equation. This is equals to minus 209. So again, I've used the completing square formula over here, okay, which we are studying since P1. If we have the expanded form ax square plus bx plus c, the expanded form of the quadratic expression. So we convert this into a completing square form by using this formula a times x plus b over 2a whole square plus 4ac minus b square divided by 4a. Okay, so I consistently use this particular form of completing square form, this formula basically. So a times x plus b over 2a whole square plus 4ac minus b square divided by 4a, and then in place of x we are going to write y, so 1 into, in place of x we are going to write y, okay, and then plus b over 2a whole square plus 4ac minus b square divided by 4a, and this will be equal to minus 209. So this means x plus 2 whole square minus 16 divided by 4 is minus 4, and plus y minus 15 whole square, and then you evaluate this 4ac minus b square over 4a, so this is minus 225, and this is equals to minus 209. So therefore the equation of the circle is x plus 2 whole square plus y minus 15 whole square is equals to 20. This is basically the completing square form, or you can say the standard form which we are looking for. So since the equation of the circle is in the form x minus a whole square plus y minus b whole square is equals to r square. So you can identify that a is equals to minus 2, or you can say minus a is equals to 2, so a is equals to minus 2 and b is equals to positive 15. Since minus b is equals to minus 15, so b is equals to 15. So the center of the circle is minus 2 comma 15, and since r square is 20, okay, so r square will be kept equal to 20, so r is equals to under root 20 units, or you can say 2 root 5 units, a simplified surd form. This was the requirement of part A. So part A, part 1 and 2 both are done. Now in the next part, it says that the line L has equation y is equals to mx plus 1, okay, where m is a constant. Given that line L is the tangent to the circle at the point P, the requirement of part B is to show that 2m square minus 7m minus 22 is equal to 0. Okay, so what we are going to do, since line L is the tangent to the circle, okay, so this means that when you substitute this line L into the equation of the circle, then you would be able to produce a quadratic equation in terms of x, okay, and in that quadratic equation the nature of the roots will be real and equal. B square minus 4ac will be equal to 0. Under that condition we need to show this equation in terms of m, which is 2m square minus 7m minus 22 is equal to 0. All right. So I'm going to substitute the linear equation into the expanded form of the equation of the circle. So x square plus mx plus 1 whole square plus 4x minus 30 into mx plus 1, I mean 4x minus 30 times mx plus 1 plus 209 is equal to 0. And then I have obtained the expansion over here. Okay, and then I can see that there are two terms which are basically in x square. In x square we have two terms. So I can say that taking x square as common, multiply by 1 plus m square. Taking x as common, multiply by 2m plus 4 minus 30m. And the constant term we evaluated, which is 180. So if we make a comparison with the form of ax square plus bx plus c is equal to 0. So a is equals to 1 plus m square, b is equals to 4 minus 28m, and c is equals to 180. C is equals to 180. Okay, so what we are going to do, b square minus 4ac will be kept equal to 0. Okay, so 4 minus 28m whole squared minus 4 times 1 plus m square into 180 is equal to 0. And then we are going to do the expansion. So 16 minus 224m plus 784m square, and then minus 4 into 1 into 180, this is minus 720, and then minus 4 into m square into 180, this is minus 720m square. And this whole thing is equal to 0, and therefore 64m square minus 224m minus 704 is equal to 0, in which we can take 32 as common. So inside you are left with the required expression. So therefore 2m square minus 7m minus 22 is equal to 0. In this way we have shown part B. So now let's move on to part C. Hence find the possible pairs of coordinates of P. So now what we are going to do, we are going to solve this quadratic equation in terms of m, and we are going to find the values of m over here. Okay, and then we are going to substitute them back into this equation which we have found in terms of m. Okay, in order to find the solutions of the equation. All right, so for that purpose I have attempted this part C over here. So 2m square plus 4m minus 11m minus 22 is equal to 0. I have shown some steps for factorization. Alternatively, you can put this equation in your equation function of the calculator and get the values of m, but you need to write a factorized form like this: m plus 2 multiplied by 2m minus 11 is equal to 0. Okay, so one value of m is minus 2 and the other one is 11 over 2. Okay, so now what we are going to do, we are going to substitute these values of m respectively into this equation. Why into this equation? Because this equation will give us the solution of the intersection between the line and the circle. Okay, and since we know the fact that b square minus 4ac is equal to 0, so this means that we are going to get repeated roots in both cases. Okay, because the line L will just touch the circle at a particular point. That point is basically P, and we need to find two possible pairs of point P. And due to this reason, we have this requirement. Hence, find the possible pairs of coordinates of P. Okay, so basically when m is equals to minus 2, so the general form of the quadratic equation is basically I'm going to substitute m is equals to minus 2 over here. So I obtained this equation: 5x square plus 60x plus 180 is equal to 0. Okay, all of these steps are more than enough to give you full marks. Okay, so that's basically the thing. So taking 5 as common, multiplied by x squared plus 12x plus 36 is equal to 0. Wonderful. We have identified that this is a repeated linear factor expression, which is x plus 6 whole square. Okay, meaning we have the complete factorized form over here: 5 times x plus 6 whole square. So x plus 6 will be equated with 0, so this will give you x is equals to minus 6. Okay, and when x is equals to minus 6, so the equation of the line has the equation y is equals to mx plus 1. So m is basically minus 2 and x coordinate is minus 6, so y is equals to 13. So one possible pair of point P is minus 6 comma 13. This makes sense. And when m is equals to 11 over 2, so I have substituted 11 over 2 into this equation in place of m. So I got this equation 125 over 4 into x square minus 150x plus 180 is equal to 0. And then I basically multiplied by 4 on both sides. And then I obtained basically the factorized form. Basically what I did, I substituted this thing into the equation function of the calculator, and I got a root of x is equals to 12 over 5. So this means that 5x minus 12 would have been kept equal to 0. And as I already know that we are going to obtain a repeated root, so 5x minus 12 whole square will be equal to 0, but the coefficient of x square is 125 over here. Okay, and when 5x is whole squared, this will give you 25x squared. So I multiplied this whole equation with 5 as well. Okay, so this is basically the completely factorized form. So 5 times 5x minus 12 whole square is equals to 0. So therefore x is equals to 12 over 5. And when m is 11 over 2, x is equals to 12 over 5. So we are going to substitute this into the linear equation. So y coordinate is 71 over 5. So the other possible pair of point P is 12 over 5 comma 71 over 5. So in this way we have found the two possible pairs of point P. One is minus 6 comma 13 and other one is 12 over 5 comma 71 over 5. So this was basically October 2024 question number 10. So for the purpose of this video, for the sake of this video, I've discussed these two possible questions. So inshallah I'll be uploading more videos. Stay tuned to my channel. Thanks for watching. And if you have any queries, you can always reach out to me on WhatsApp. I'll be more than happy to help anyone out there. So happy learning. Stay tuned to my channel. Stay blessed. Assalamu alaikum.